In the last video we talked about the law of sines, and we said that in order to use the law of sines we needed to have a given angle across from a given side, or we needed to be able to find an angle that was across from a given side. And so we used angle, and angle, side to describe those things. And that resulted in one triangle. We were able to solve the triangle and find the missing sides. We also talked a little bit about this other case, this case of side-side angle, which we lovingly call the donkey. And it also is derived from the law of sines. But it's not a congruence postulate. In fact, if you're given two sides, like say side B and C, and then an angle that's not between them, like a B or a C over here, then what you have is you have three possibilities. We have a possibility that the triangle will be one triangle, two triangles, or no triangle. Now, on this video, I want you more than anything to take in some of these concepts, stop the video, and think about what you just heard. Don't just copy it down off of here, but actually take a few minutes to think about what we're trying to accomplish. This isn't easy to see, and I've done some things on the video that should make it a little easier, but you're going to have to think about this and then write the notes accordingly. Okay? Alright, I want you to stop the video and write some of this down, but these are some things that we need to remember. And this is stuff from geometry that you should still remember. The sum of the interior angles of a triangle are 180. No triangles can have two obtuse or two right angles for that matter. This idea that the sine function has a range between -1 and 1. What that means is that if I had the sine of an angle, A, that ratio, if I put that in there, is going to have to be between -1 and 1, or you get an error on your calculator. Okay? And angle A could be in degrees or radians. So the other thing, number 4, talks about on the coordinate plane that sine, where is sine positive? Well, sine's positive in the first quadrant and the second quadrant. And if you think about angles, this is 0 to pi over 2, or 90 degrees, and this is 180 degrees, right? So any angle in the first quadrant is going to be acute, right? And any angle in the second quadrant is going to be obtuse. So that's real important to remember these 4 things before we move on to the ambiguous case of the law of sines. Okay, here we go. These are images of the possibilities that you could get using the law of sines to solve a triangle if you are given side-side angle configurations. Okay, so for instance over here, here's angle A, and we have a side opposite angle A, right? There's side A, and then we have another side over here, B, and the angle across from B, if it existed, would be angle B, right? But it doesn't even exist in this triangle. Okay, this H right here we talked about in the last video is the height, or the altitude of the triangle, right? H. And to find H, you can see that this right here is a right triangle, so the sine of angle A is H over B, and you can see that written here. If I multiply both sides by B and switch the sides, you have H is equal to B sine A, and that A is the angle. Alright, so there's 4 possibilities. One possibility is that this side A, the given side, is less than B. And if that's the case, then it does not make a triangle, right? This is too short to make a triangle. The other thing you can realize here is that A is less than H as well, right? So there's just no way it doesn't reach over here. Okay, the second possibility is that A and H are the same height. So if I calculated B times the sine of this angle, that would get me H. H and A are the same. Remember that angle A and side A are given. and side B is given. I'm sorry, I'm getting that backwards. All right, and so if H and A are the same, it makes one triangle, and further, it's a right triangle. Okay. The third possibility is that A, the side A, is longer than the given side B, and it's also longer than H. And if that's the case, it's just one triangle. Now here is the stickler, the one that everybody seems to have trouble with, and it's this two triangles. It would make two triangles. And in class, I'm going to show you with the ang legs what this looks like. But you can see here that I'm given the angle A, the side opposite here, and another side angle. Here is the height of my triangle. And what you notice here is that A and H, or A, is somewhere between H and B. And what you get, it looks like there's, two here, but you can see, I'm going to draw it like this. You can see this. That's one triangle. And then using those same ones, you can get this one. So there are two triangles that are possible. Okay. Now, you'll notice that in all of these triangles, 1, 2, 3, 4, they're all acute. So in an acute triangle, you have these four possibilities. Now, don't panic, because there is an easier way to determine what situation we have. And notice this is only with the law of sines. Okay, if you have an obtuse triangle, like we do here, we have only two situations. Right? We're still given the same angle A, the side opposite, and another side angle. If A is greater than B in an obtuse triangle, you just have one triangle. And if A is less than B, you've got no triangles. So in an obtuse triangle, you really only have two possibilities, and neither of them are two triangles. So we're going to have one instance only that's going to give us two triangles. First, the original triangle has to be acute, and then the sides have to be a certain length. Okay, so here we go. We're going to try one of the examples. This is, the example here shows you that angle A is 85 degrees, side A, the side across from it, is 15, and side B, the other given side, notice here is side angle, is 25. Alright, so the first step is to find the missing angle across from the given side. And if you get an error here, there is no triangle. So I'm going to write the sine of 85 degrees over 15 is equal to the sine of B over 25. Alright, so once again, we remember we're going to hit on our calculator 25 times the sine of 85, hit enter, divide that by 15. And we're going to get that the sine of B, the sine of B is equal to 1.66. Now remember from before when we said one of the things that sine has to be between -1 and 1. But just to prove it, I want you to hit second sine of 1.66 on your calculator. Now, you're going to get an error. My calculator said domain error, which is fine, but that just means that there is no triangle. Now, if we look at this again, we'll see that A was less than B and probably was bigger than H, and so there's no triangle. Okay, here's another example. We have A is 20.5, we have the side opposite is 20, and B is 12. And so we want to do this again. We're just going to start by finding the missing angle across from the given side. So we have the sine of 20.5 over 22 is equal to the sine of B over 12. Alright, so once again we're going to do 12 times the sine of 20.5. We're going to divide that by 22. And I hope you're trying it. And we'll get the sine of B is 0.191022, or something close to that. Is that between -1 and 1? Well, yes it is. So second sign, second answer, or put this in for second sign, angle B is going to equal 11.012, and if you're okay, I'm just going to call it 11 degrees. All right. Number 2 says subtract that angle, angle B, so I'm going to do 180 minus B, and B is 11, so that's going to give me 169 degrees. Okay, now I'm going to add that 169 to the original angle, which was given 20.5, and that gives me 189.5 degrees. Well, here's the deal. If only two of the angles add up to more than 180, then this cannot make two triangles. So this is going to be just one triangle. So if this becomes bigger, now remember on the previous one we got an actual error. If it's an actual error, then it's no triangle. On this one, it will just be one triangle. If this is 189.5 with two angles, it will not make a second triangle. So we'll just solve for the rest. Well, we're looking for, we have B, we're looking for C, and we're looking for side C. And so we found angle B. Angle B was 11 degrees. We can find C by just taking 180 minus 20.5 minus 11, and that's going to give me 148.5 degrees, which is rather large. And then to find C, I just take the sine of 148.5 degrees over side C, and then I'm just going to go back and use the original. I could use B, but since I rounded a little, I'm just going to go back to the original. 20.5 over 22. And when I do that problem, I'm going to do 22 times the sine of 148.5 divided by the sine of 20.5 to get 32.82. So I hope you'll check my math and make sure that that's correct. Okay, here's our final example. Guess what? This one is going to be the two triangles. This is two triangles. And so you see the given information up here in the corner, right? We're going to do the same method, the same exact thing we did before. We're going to find the missing angle across from the given side. So I've got the sine of 20.5 over 12 is equal to the sine of B over 31. Okay? And when I multiply sine of 20.5 times 31 and divide by 12, I get the sine of B is equal to 0.904. Second answer gives me the angle B, which is 64.78 degrees. And I'm going to leave it 64.78. I'm going to leave that. Okay, step 2 says take that from 180. So I'm going to subtract, and that's going to equal 115. 115.21. Okay, so if I add 115 and 20, is it going to be less than 180? Well, the answer to that is yes, less. So that means there could be two triangles. Well, there will be two triangles. All right, so think about this a minute. The information that we're trying to find is we need to find B, angle C, and side C. So the first time that I calculated B, I got it to be 64.78 degrees. Remember that the two angles are related. The two angles are related. So angle B in the second triangle is going to be 180 degrees minus the original, and that will be the 115.21 degrees. So these two triangles are related, these two angles, angle B, the original angle, in that they add to 180 degrees, and that's why I'm subtracting there. They have to add to 180 degrees. They are supplementary. Okay, so I have that triangle, and then I have this. So these are the two triangles. Now, remember how you find the third angle. So I'm going to work over here with this triangle right here. Right, so I'm going to get C by taking 180 minus 20.5 minus 64.78, and that's going to get me 94.72. I have it worked out over here. All right, and then to find C, I'm going to take the sine of 94.72 over C equals the sine of 20.5 over 12. And so for C, I'm going to get 34.15. Okay. Over here, to get this C, I'm going to do 180 minus 115.21 and 20.5. And that's going to give me a much smaller angle, 44.29. And so in this triangle, to find the third side, I'm going to do my original, the sine of 20.5 over 12 equals to the sine of 44.29 over C. And for that one, I'm going to get 23.97. Okay. Okay, so here's what's going on in that problem. In the original problem, I have 20.5 degrees for angle A, and the side opposite angle A is going to be 12. Okay, the side over here, or B, side B, is 31. Okay, and so when I did the first calculation, I found, this is C, and then this is little c. The first calculation, I found this angle, right? I used the law of sines and found this angle to be 64.78. Okay, so in this triangle then, in order to find the angle C for this triangle, I would take 20.5 and 64.78, subtract from 180, and get C. And we got C, it was 94.72. And that makes sense, right? And then I used this to find this C, and this was 34.15. That's in triangle 1. Now, the other thing that I found was the second triangle. And what we found was that this was long enough that it was here. This is still 12. But this is the second B angle. And this angle here, this angle, and this angle add up to 180 degrees. So these add up to 180 degrees. Now, that's pretty cool, but it also makes a different triangle. So notice up here that C changes. In the blue triangle, this was all C. Now it's just this. Okay? So if this is supplementary, we found this angle right here, this B, to be 115.21. Well, that's going to change everything, because you have 20.5, 115.21, and so we found this C angle to just be 44.29, much smaller. Well, if this changes, then this C is also going to change. So you end up having C and C prime. You end up having this C right here, this is C, and then you have this one, which is C prime. So that's what we're finding. We're finding the two triangles, and this doesn't happen every time, but this is what's happening when it does. And it's because we're dealing with side-side angle, and that it is not a congruence postulant. It could be one of those three things. Okay, here is the process, set up the ambiguous case of the law of sines, and your homework problem, the problem I need you to work before tomorrow. and that's at the bottom. But I want to go through this real quickly. This is where we start. You're going to solve for the unknown angle across from the given side. If you get an error, no triangle. If there is no error, you're going to subtract what you got up here from 180 and add to the given angle. If it's negative, then it's just one triangle. That's all you need. But if it goes to here, it's two triangles. And you'll need to solve for both triangles. Okay? Copy these notes down, and I'll see you in class. I suspect I'll need to go over this again, and that's okay.